Okay guys, welcome back to another video. Today we will use the principle of mathematical induction to prove divisibility. Let's start with 8 divide 5 raised to the power of 2n plus 7. So I gotta prove this divisibility for all n by using the principle of mathematical induction. So do not forget that to use the mathematical principle induction, we need to have Pn, which is a statement with n, which is an integer. And we have to start with the base step, which is the case where n equal to 1 and show that P1 is true. So once you have shown the base step, you have to show the inductive step, is that you have to assume that P of k is true for any integer k and try to show that P of k plus 1 is true. Now let's start to prove this one. 8 divide 5 raised to the power of 2n plus 7. So we have to start with this proof and let Pn be this statement 8 divide 5 raised to the power of 2n plus 7. Okay, be this statement. And we have to start with base step. Okay, base step. Alright, so what is P of 1? So we start when n equals 1, so we're gonna have 5 raised to the power of 2. 2 times 1 plus 7, which is 25, plus 7, which is 32. And 32 is divisible by 8, so it turns out to be 4 times 8. It's 4 times 8. Okay? It's 4 times 8. So by divisibility, what do we have? So by divisibility, so we have 4 times 8. This means that 8 divide 5 raised to the power of 2 times 1 plus 7. Okay, so that means that P of 1 is true. Okay, that means that P of 1 is true. And next one is inductive step. Okay, inductive step, what do we have for inductive step? So we have to assume that P of k is true for any integer k. Okay, what do we have to try to show? We have to show that P of k plus 1 is true. Now, since we assume that P of k is true, so right now we gotta have, so we will have 8 divide 5 raised to the power of 2k plus 7. Okay, hence there exists an integer, let's say q, such that 5 to the 2k plus 7 equal 8q. That's what we have right now. And we want to try to show that pk plus 1 is true. So we gotta have 5 to the 2k plus 1 plus 7 equal 5 to the 2k plus 2 plus 7. Now try to write it. For this one, I'm going to partition this number 2 here. So we're gonna have 5 to the 2 times 5 to the 2k plus 7. Then we're gonna have 25, 5 to the 2k plus 7. So I have to show that this number has 8 as a factor. So right now it cannot factorize 8 out of these two terms. So what I have to do is to try to use pk, which is true, to be a useful tool. So I want to do this. I want to use number 7 so that I can have the factor of 8. So I gotta add some terms here. So I gotta add 25k, okay, and subtract 25 7, okay. So add 25 7 plus and minus 25 7. This number k remain the same, so we're gonna have 7 right here. So I just add and subtract. Now what can we do next? What I want to do is to look at these two terms here, right here. So we have 25 as a factor. So I have to factorize 25, so it turns out to be 25 times 5 raised to the power of 2k plus 7 minus, okay, minus 25, 7 plus 7, it turns out to be 24 times 7. And what is this term? 8q, right? Okay, so since pk is true, this term has a factor of 8, so it turns out to be 25 times 8q minus 24 times 7. Let's continue here. So we gotta have 5 to the k, 5 to the 2k plus 1 plus 7. And right now, we are going to factorize number 8. So we gotta have 8 times 25q minus 3 times 7. So it turns out to be 8 times 25q minus 21. So that means that this number has 8 as a factor. Okay? So therefore, by divisibility, we can have 8 divided 5 raised to the power of 2k plus 1 plus 7. Okay? So therefore, what do we have? Therefore, pk plus 1 is true. So we have shown that 8 divided 5 raised to the power of 2n plus 7, which is true for any integer n, okay? Actually, for any positive integer n. Alright? So that's what we have here, okay? So, that's it for today, and see you in the next video.